A circuit breaker is designed to protect an electrical circuit from overcurrents, but in some situations, a breaker might not trip immediately, even when the current exceeds its rating. The breaker in question is a thermal magnetic type. Thermal magnetic breakers have two primary mechanisms for tripping: firstly, the thermal element, and secondly, the magnetic element. The thermal element is a bimetallic strip that heats up when current flows through it. If the current exceeds the breaker's rating, the strip will heat up and bend, eventually tripping the breaker. This type of tripping is time delayed, meaning it takes longer to trip the breaker with a slight overcurrent than with a large overcurrent. The magnetic element is an electromagnet that trips the breaker instantly when a large surge of current flows through it, such as during a short circuit. This protects the circuit from immediate and potentially damaging high current events. In the situation described, the current draw was between 35 and 38 amps on a 30 amp breaker. This represents an overload, but not a short circuit. Therefore, the magnetic element would not have been activated. The thermal element would have been responsible for tripping the breaker. However, the thermal element did not trip within the 10-minute test period. There are several reasons why this might have happened. One reason is the tolerance of the breaker. Circuit breakers are not precision devices and have a tolerance range within which they are expected to operate. A 30 amp breaker might not trip exactly at 30 amps. It could trip at a slightly higher current, such as 32 or 33 amps, due to manufacturing variations and design tolerances. The overload current of 35 to 38 amps might have been within the breaker's tolerance range for a short period. Another reason is the time current characteristic of the breaker. Breakers are designed to allow short-term overloads without tripping, which prevents nuisance tripping from momentary current spikes. The time current characteristic curve defines how long a breaker will take to trip at different current levels. A slight overload, such as the one observed, might not cause the breaker to trip within a short time frame like 10 minutes. The breaker's internal temperature also plays a role. If the breaker was initially cool, it would take longer for the thermal element to heat up and trip. The ambient temperature around the breaker can also affect its tripping time. Higher ambient temperatures can cause the breaker to trip sooner, while lower temperatures can delay the tripping time. The warm conductor observed is indicative of the overcurrent situation. When a conductor carries more current than it is rated for, it will heat up. The heat generated is proportional to the square of the current, so even a small increase in current can lead to a significant increase in heat. In this case, the 10/2 copper Romex cable was likely overheating due to the sustained overcurrent. Using the wrong size breaker for a particular wire gauge is a common and dangerous mistake. The National Electrical Code, or NEC, specifies the correct wire gauge for different circuit breaker sizes. For example, a 30 amp breaker typically requires a minimum of 10 AWG copper wire, while a 40 amp breaker requires a minimum of 8 AWG copper wire. Using a smaller wire gauge than required can lead to overheating, insulation damage, and potentially a fire. Installing the correct 40 amp circuit with appropriately sized wiring is essential to ensure the safety and proper operation of the range. The NEC specifies that branch circuit conductors serving a range shall have an ampacity not less than the rating of the range. In addition, the branch circuit overcurrent protection shall not exceed the ampacity of the branch circuit conductors. For a 40 amp circuit, 8 AWG copper wire is typically used. However, it's important to consult the NEC and local codes to determine the exact requirements for the specific installation. The continuous load theory is also relevant in this situation. A continuous load is defined as a load that operates for 3 hours or more at a time. The NEC requires that the overcurrent protection device be rated at not less than 125% of the continuous load. This means that for a continuous load of 32 amps, the breaker must be rated at least 40 amps. 32 amps x 1.25 equals 40 amps. This requirement is intended to prevent nuisance tripping and ensure that the breaker can handle the sustained load without overheating. Dating is another important consideration. Dating refers to reducing the ampacity of a conductor based on factors such as ambient temperature, the number of conductors in a conduit, and the type of insulation. The NEC provides tables that specify the dirting factors for different situations. It's important to apply the appropriate dirting factors to ensure that the conductors are adequately sized for the expected load and operating conditions. In summary, the 30 amp breaker did not trip immediately due to a combination of factors, including the breaker's tolerance, time current characteristic, and internal temperature. The warm conductor was a clear indication of an overcurrent situation, and it's crucial to replace the undersized breaker and wiring with the correct 40 amp circuit to ensure safety and prevent potential fire hazards. Always consult the NEC and local codes to ensure that all electrical work is performed in accordance with applicable regulations. When dealing with electrical systems, safety should always be the top priority. It's essential to understand the principles of overcurrent protection, conductor sizing, and dirting to ensure that electrical installations are safe and reliable. If there is any doubt about how to perform electrical work safely, it's always best to consult a qualified electrician. The NEC provides detailed guidelines and requirements for electrical installations. Following these guidelines is essential to ensure the safety of people and property. Circuit breakers are an essential safety device in electrical systems. They are designed to protect against overcurrents and short circuits, which can cause fires and other hazards. Understanding how circuit breakers work and how to select the correct size breaker for a particular application is crucial for electrical safety. Regular inspection and maintenance of electrical systems are also important. Circuit breakers should be tested periodically to ensure that they are functioning properly. Wires and connections should be checked for signs of damage or deterioration. Any problems should be addressed promptly to prevent potential hazards. Electrical work can be dangerous, and it's important to take precautions to protect against electric shock and other injuries. Always turn off the power to a circuit before working on it. Use insulated tools and equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. Never work on electrical systems when you are wet or standing in water. Electrical safety is everyone's responsibility. By following these guidelines and taking precautions, you can help prevent electrical accidents and ensure the safety of yourself and others. Proper electrical work requires careful planning and attention to detail. It's important to understand the load requirements of the circuit, the ampacity of the conductors, and the characteristics of the circuit breaker. Using the wrong size breaker or wire can create a dangerous situation. For example, using a 30 amp breaker on a circuit that requires a 40 amp breaker can lead to nuisance tripping and potential overloading of the circuit. Using a wire gauge that is too small for the breaker size can cause the wire to overheat and potentially start a fire. Always consult the NEC and local codes to determine the correct size breaker and wire gauge for a particular application. If you are unsure about any aspect of electrical work, it's always best to consult a qualified electrician. An electrician has the training and experience to perform electrical work safely and in accordance with applicable regulations. Attempting to perform electrical work without the proper knowledge and skills can be dangerous and could result in serious injury or death. It's also important to be aware of the potential hazards associated with working on electrical systems. Electric shock is a serious hazard that can cause burns, muscle contractions, and even death. Always take precautions to protect against electric shock. Wear insulated gloves and shoes when working on electrical systems. Use insulated tools. Never work on electrical systems when you are wet or standing in water. Another potential hazard is arc flash. Arc flash is a dangerous electrical explosion that can occur when a short circuit or other fault occurs in an electrical system. Arc flash can cause severe burns and other injuries. Always wear appropriate personal protective equipment when working on electrical systems that could potentially produce an arc flash. The specific personal protective equipment required will depend on the voltage and current levels of the system. In addition to these hazards, there are also potential fire hazards associated with electrical systems. Overloaded circuits, loose connections, and damaged wiring can all cause fires. Always inspect electrical systems for signs of damage or wear. Replace any damaged wiring or components. Ensure that all connections are tight and secure. Never overload circuits by plugging too many devices into a single outlet. By taking these precautions, you can help prevent electrical fires and protect yourself and others from harm. Electrical safety is an ongoing process. It's important to stay informed about the latest electrical safety standards and practices. Attend training courses and seminars. Read industry publications. Consult with qualified electricians. By staying up to date on electrical safety, you can help ensure that your electrical systems are safe and reliable. Remember that electrical work should only be performed by qualified individuals who have the necessary training and experience. If you are not qualified to perform electrical work, always hire a licensed electrician. An electrician can perform the work safely and in accordance with applicable regulations. Attempting to perform electrical work without the proper qualifications can be dangerous and could result in serious injury or death. The information provided in this narration is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work.